Well, we have already seen the first type of combinational circuit, that is multiplexer. Today we will discuss about the second type of combinational circuit, that is demultiplexer. Now, to come to the definition of the demultiplexer, is a type of combinational circuit which will have only a single input line, whereas the number of output lines will vary from 2 to the power n. Depending on the power of n, the value of n, we will have different output lines for a single input line. Now, multiplexer, we have already seen that there is a single input and multiple output, whereas the information that is received from a single input, it is directed into multiple output lines. Now, on the basis of the selection lines, the input will be connected to these outputs. Demultiplexer will operate just in the reverse way of the multiplexer. That is, on the basis of the select lines, the input lines will be directed to the 2 to the power n output lines. Like encoder and decoder, there are n selection lines and 2 to the power n outputs for a demultiplexer. Now, in demultiplexer, like multiplexer in short, it is known as mux. Demultiplexer will be known as demux. Now, let us come to the first type of demultiplexer, that is 1 into 2 demultiplexer. Here, 1 into 2, this simplifies, 1 simplifies that we will have a single input line, whereas we will have the two different outputs. We will denote these as y0 and y1. And here, in this case, we will have a single selection lines, S0, and a single input, that is A. Now in C, on the basis of the selection value, the input will be connected to one of the outputs. The block diagram, here you see the block diagram, we have a single input here as A, whereas we have the two different outputs as Y1 and Y0. And the selection line is denoted as S0. Now you see the truth table of this particular 1 into 2 demultiplexer. That is, whenever S value is 0, the Y0 is A. Whereas when the S0 value is 1, Y1 value is A. In the other times, Y1 and Y0 is 0. Now, on the basis of the truth table values that it is generated, we will have to write the Boolean expression. So, this is the Boolean expression for the final output, that is y. You see, y0 is denoted as s0 bar a and y1 is s0 dot a. Now, since we have a complement of S0, so we need an NOT gate for its construction by using the for the logical circuit. So you see here the first part S0 bar. So it is connected. S0 is connected to a NOT gate, and the final one is connected to the this particular AND gate, where we have the one of the inputs from A, that is y0, that is s0 bar, and a is y0, and we have the second one, that is a and s, that is y1. So this is the logic diagram of the final output y0 and y1. In the next type of demultiplexer, that is 1 into 4 demultiplexer, here we will have one inputs and we will have four different outputs. We denote them as y0, y1, y2 and y3. In this case, we will have two different select lines, s0 and s1. So you see, we will have the different combinations of the output are denoted in this particular truth table on the basis of the combination of the inputs that we provide, and on the basis of the select lines. Here we have two select lines, and therefore we will have 2 to the power 2, that is four different possible combinations of the input for S1 and S0. See here in the truth table itself, you can see here that S0, S1 and S0, 0, 0, 0, 1, 1, 0 and 1, 1. Now as you can see in this particular block diagram, we will have four different combinations of output, that is y0, y1, y2 and y3, and these are the truth table. So for the first case, the y0 value is a. For the second case, that is 0, 1, the y1 value is a. In the third case, 1, 0, the y2 value is a. And for the fourth case, that is 1, 1, the y3 value is a. Now, according to the truth table that is generated, we can design the Boolean expression for y0, y1, y2, and y3. See here, y0 is s1 complement s0 complement a, y1 is s1 complement s0 a, y2 is s1 s0 complement a, and y3 is s1 s0 a. So you see, for the complements we have used here NOT gate, and for the other inputs we have directly connected to the AND gate, and you see that we have there are three input AND gates that are used, and we get the four different outputs. Moreover, this is up till the first part of the demultiplexer. The higher order demultiplexer design is also possible, that is 8 into 1, uh, 1 into 8 marks, D marks, and 16, 1 into 16 D marks. Moreover, these topics will be covered later on, and this is beyond the scope of this particular video. So, thank you. We will see in the next part of our session very soon.